We often think of the scientific revolution in terms of what it gave us. Telescopes turned toward the stars, equations scribbled across chalkboards, and the clash of new discoveries with ancient doctrines. It's the age of Galileo peering into the night sky, of Newton watching apples fall, of knowledge becoming something you could measure and test. But beneath that surface, beneath the dazzling instruments and groundbreaking observations, was something even more radical. Something quieter, but no less profound. It was a revolution not just in what we knew, but in how we knew. A shift in the very foundation of thought itself. Because before anyone looked through a telescope or formulated a hypothesis, they had to believe it was possible and permissible to question, to doubt, to imagine a world governed not by unquestioned authority, but by patterns that the human mind could uncover. And that belief? That came from philosophy. The real beginning of the scientific revolution wasn't in the lab or the observatory. It was in the study, in the solitude of thinkers like Descartes, Bacon, and Galileo. Men who didn't just do science. They reimagined the rules of truth. So in this video, we're not just recounting discoveries. We're excavating the deeper shift beneath them. A shift in consciousness. A philosophical awakening that made science, as we now know it, possible. And to understand that, we have to go back. Back to a world where knowledge wore the robes of tradition, and truth was something handed down, not earned. To truly grasp the magnitude of the scientific revolution, we have to begin in the world that came before it. A world where the idea of questioning nature, let alone redefining truth, was not just rare. It was radical. Imagine a time when knowledge wasn't built through discovery, but received through tradition, where truth was something preserved, not pursued. In medieval Europe, the prevailing intellectual framework was scholasticism, a system that fused Christian theology with the ancient philosophy of Aristotle. It was intricate, logical, and deeply reverent. But it was also confined. Aristotelian physics, with its crystalline spheres and fixed heavens, dominated the understanding of the cosmos. The Earth, unmoving and central, was surrounded by orderly layers that carried stars and planets in perfect circles. Things moved, it was said, because they were fulfilling their natural purpose. Stones fell to the ground because they belonged there. Fire rose because it sought the heavens. It was elegant. It was complete. And it left little room for experimentation. In this world, to question Aristotle was to question the Church. And to question the Church was to question divine order itself. So knowledge was built not on the foundation of observation, but on the pillars of authority. Ancient texts, sacred doctrine, inherited wisdom. Philosophy, too, was largely deductive. Thinkers reasoned from general truths to particular conclusions. If a principle was held to be true, whether from scripture or classical logic, then everything else had to align with it. There was little room for doubt, even less for data. But quietly, cracks had begun to form. The world was changing. Curiosity was stirring. And a few brave minds began to ask, what if authority could be wrong? What if truth could be found, not in books, but in the world itself? If the world before the scientific revolution was built on received wisdom and sacred authority, then Francis Bacon was one of the first to challenge its very foundation, not by tearing it down in rebellion, but by proposing something far more radical, a new way of knowing. Bacon wasn't merely a statesman or a scientist. He was a philosopher of method. He looked at the prevailing systems of thought, the towering structures built on Aristotelian logic and theological tradition, and saw something deeply flawed. It wasn't just the conclusions that were wrong, it was the process by which people arrived at those conclusions. The method itself, he believed, had to change. And so he offered a critique, not of individuals, but of the human mind. In his seminal work, Novum Organum, Bacon spoke of the idols of the mind. systematic errors and illusions that cloud our judgment. These idols came from language, culture, personal bias, and even our unexamined reverence for tradition. They made us believe we understood the world when, in truth, we were only repeating inherited assumptions. To overcome this, Bacon championed something revolutionary: inductive reasoning. Instead of beginning with grand theories and working downward, as Aristotle had, Bacon urged thinkers to start with observation, with the world, with careful, repeated experimentation. From there, patterns could emerge. Laws could be inferred. Knowledge, he believed, should be built bottom-up, not top-down. But this was not just a technical shift. For Bacon, science wasn't some abstract exercise. It was a moral and humanistic mission. He believed that knowledge, properly pursued, should uplift humanity, relieve suffering, improve life. It was a tool of empowerment, not elitism. And that belief gave empirical science a spiritual weight. It made it a calling. Novum Organum wasn't just a book of methods. It was a vision, a call to action, a quiet revolution that whispered, "Don't just trust the ancients. Look with your own eyes. Experiment, observe, doubt, discover." And though Bacon's own hands rarely touched the instruments of science, his fingerprints are on everything it became. He planted the seed of a new intellectual ethic, one that would soon be watered by minds equally restless, equally brave, but drawn to different paths, like the rational clarity of Descartes. While Francis Bacon called us to the world, to observe, to touch, to test, René Descartes invited us inward, into the mind, into the shadows of doubt, into the very structure of thought itself. If Bacon was the father of empiricism, then Descartes was his philosophical counterweight, the architect of rationalism. And though their methods diverged, their goal was the same: to rebuild knowledge from the ground up. Descartes' journey began not with data, but with distrust. He questioned everything: his senses, his memories, even the reality of the world around him. What if it was all illusion? What if nothing could be known for certain? And in the midst of that abyss, he found a single, unshakable truth. Cogito, ergo sum. I think, therefore I am. That sentence didn't just assert his existence. It became the cornerstone of a new way of knowing. Descartes believed that true knowledge had to begin with absolute certainty, and from there, be built through the clarity of reason. Mathematics, with its pure, undeniable logic, became his ideal. He envisioned the universe as a vast mechanical system, a kind of clockwork machine governed by laws that could be uncovered not through sensation, but through deduction. In this view, nature was not mysterious or mystical. It was orderly, structured, and above all, intelligible. If you could understand the parts, you could understand the whole. And to understand, you had to reason clearly, systematically, without the clutter of superstition or the noise of untested beliefs. Yet here lies the paradox. Descartes distrusted the senses. He warned us that they could deceive. And yet, his philosophical clarity ultimately helped legitimize the scientific method. Because by emphasizing structure and method in thought, he helped shape how we approach the observation of the world. His rationalism provided the scaffolding on which later scientists would hang their data. Even observation, to be meaningful, had to be guided by reason. So while Bacon urged us to look outward, Descartes taught us how to think inward. Together, they didn't just challenge the old order, they offered a blueprint for a new one. And that blueprint would soon find its most daring expression in a man who dared to gaze at the stars and declare that the heavens too obeyed laws. If Bacon gave us the method and Descartes gave us the reasoning, then Galileo gave us the vision, the audacity to point a lens at the heavens and say, "Let's see for ourselves." He wasn't just a scientist recording data. Galileo was a philosopher in motion, bridging the abstract world of ideas with the tangible world of observation. In many ways, he stood at the crossroads between two worldviews, one ancient and secure, the other new and uncharted. When Galileo first turned his telescope to the night sky, he didn't just discover moons orbiting Jupiter, he shattered a cosmic hierarchy. According to Aristotle and the Church, the heavens were supposed to be perfect, immutable, centered entirely around Earth. But here was proof, visible, undeniable, that not everything revolved around us. The universe, it seemed, had a logic that didn't care for our pride. But Galileo didn't stop at observation. He brought mathematics into the equation, literally. He began to describe motion, force, and trajectory using numbers and formulas. In doing so, he gave science a new language, one that could speak clearly, one that could be tested, repeated, refined. He saw nature not as a chaos of experiences, but as a system governed by discoverable laws, and math was the key to unlocking them. His dialogue concerning the two chief world systems wasn't just a scientific work, it was a philosophical earthquake. In the form of a dialogue, Galileo explored the Copernican model versus the Ptolemaic system, embedding arguments for heliocentrism in lively human conversation. It was daring, almost theatrical, and it spoke not just to the mind, but to the soul. It asked people not just to rethink astronomy, but to rethink their place in the universe. And that was dangerous, not because Galileo had broken some physical law, but because he had defied a deeper authority, the philosophical structure that held society together. The Inquisition didn't silence him because he observed moons. They silenced him because he implied that truth could exist beyond the bounds of sanctioned tradition. Galileo's fall was not the end of the revolution, it was its ignition. His courage, his clarity, and his conviction showed that science was not just about facts, it was about freedom. And that freedom, like all revolutions, began with a deeper shift in how we ask questions, how we trust our minds, and how we seek to know. As the dust settled from the early waves of the scientific revolution, something subtle but deeply profound began to emerge. The telescopes, the mathematics, the empirical methods, these were the tools. But the real shift was happening somewhere deeper. It was no longer just about what the universe was made of, or even how it worked. It became a question of something far more intimate. How do we know anything at all? This was the moment when philosophy, once concerned with the grand architecture of being, what we call metaphysics, turned its gaze inward. It began to ask not about the stars, but about the observer. Not about truth as a cosmic structure, but about the human capacity to perceive, to reason, to understand. Thinkers like Descartes, Locke, and later Kant moved the conversation from the nature of reality to the nature of knowledge. What counts as certainty? What are the limits of reason? Can we trust our senses? And if not, what remains? This was the birth of modern epistemology, the philosophy of knowledge. It laid bare the assumptions that had quietly guided science and insisted that even the act of observing must be examined. That to know the world, we must first know the knower. And this mattered because science was not just gathering data. It was building meaning out of experience. And meaning, inevitably, passes through the filter of the mind. By tracing the edges of what the mind could grasp, philosophers helped define the shape of scientific inquiry itself. That quiet turn inward, away from metaphysical speculation and toward epistemological clarity, didn't end the revolution. It deepened it, and it prepared the ground for a new kind of intellectual ethos, one where philosophy and science would walk hand in hand, each sharpening the other. We often talk about the scientific method as though it were a neutral tool, like a microscope or a ruler. But in truth, it's something far more profound. The method itself, the process of observing, hypothesizing, testing, and refining, is a philosophical creation. It's a fusion of two traditions: Bacon's call to the senses and Descartes' call to reason. One urged us to look outward, the other inward. Together, They shaped a way of thinking that still defines science today. And look closely at the values science holds dear: skepticism, falsifiability, clarity, logical coherence. These aren't inventions of laboratories. They're ideals born in the heart of philosophy. The idea that a claim must be testable, that every conclusion must be open to revision, that truth emerges not from certainty but from questioning. All of it is deeply, unapologetically philosophical. Even as science evolved, its philosophical roots kept growing. Immanuel Kant asked how the structures of the mind shape what we perceive. Karl Popper challenged the idea of proving theories, arguing instead that true science must be falsifiable. And Thomas Kuhn reminded us that even scientific paradigms are shaped by the culture and beliefs of their time. What we call science is not some cold, mechanical process. It's a living dialogue between evidence and interpretation, between data and doubt. It stands not apart from philosophy, but upon it. And every breakthrough, every paradigm shift, carries within it the echo of ancient questions. What is truth? How do we know it? What does it mean to understand? Science has given us tools, yes, but philosophy gave us the courage to use them. And that legacy continues, not as something we leave behind, but as something we carry forward into the questions we've yet to ask. The scientific revolution was not just a burst of discoveries, it was a transformation of thought. A reimagining of how we ask questions, how we trust our minds, and how we relate to truth. It wasn't a rejection of philosophy, but its evolution. Philosophy didn't step aside so science could emerge. It lit the path. From Bacon's empirical gaze to Descartes' rational clarity, from Galileo's mathematical cosmos to the birth of epistemology, we've seen how every step in scientific progress was also a step inward, toward a deeper reflection on what it means to know. Science was never built on data alone. It was shaped by ideas, by doubt, by courage. And now, in an age shaped by artificial intelligence, quantum uncertainty, and ethical dilemmas that stretch the boundaries of our imagination, we have to ask, can we afford to forget where science came from? Can we afford to sever it from the philosophy that gave it meaning? Because the real power of science lies not just in discovering new facts, but in honoring the process of discovery, where reason, reflection, and evidence move together in dialogue, not as rivals, not as strangers, but as partners in the oldest human quest of all, to understand.